Alright, welcome to the last video where we're going to go over everything on the 6th page, starting with number 21. For number 21 and 22, we're converting between radians and degrees. So remember, we need to know our conversion factor, which is 180 degrees equals pi radian. Or we could always say 360 degrees is equal to 2 pi, whichever one you're more comfortable with. When we're using these, we have to remember which one goes on top, which one goes on the bottom when we're converting, and this is when I like using the T-chart method. So if we look at number 21, we have negative 7 pi over 6. This is in radians, and we can tell that because it has the pi symbol and because there's no degree symbol. So with the pi there, it especially makes it easy to remember how we need to set up our conversion factor. Pi's on top, so for our conversion factor, pi needs to be on the bottom, so that way it cancels each other out. So that means 180 is on the top. So when we do that in our calculator, we would get negative 7 times 180 degrees divided by 6. So when we do that math out, it surprisingly cleans up pretty well to negative 210 degrees. That's our answer there for number 22. This one's a little bit more complicated because we have to clean up some fractions, because I would prefer you to keep it in exact form. So we have 290 degrees. When we set up our T-chart, we want the degrees to be on the bottom, so that way they cancel out, which means 180 needs to go on the bottom and pi needs to go on the top. Now we're trying to figure out, can we simplify this fraction in any way? We have 290 pi over 180. Right away, I can cancel out the zeros. I can take a 10 out of both at the top and the bottom. And now I need to simplify, see if there's any way that a number goes into both 29 and 18. When I think about this, 29 is prime. So that means there's no way to clean it up. So I have 29 pi over 18. That's the answer that would be correct on your test. That will be what your answer looks like. So for some reason you wanted to clean up and think going the decimal way is the right answer, you would get 1.611 pi or 5.601 as just a decimal, but those won't be as a multiple choice answer on the test. So you will be very confused trying to compare these answers with the one in the box, because they look very different from each other. So try to keep exact. Or in the worst case, take the exact answers on the test, convert them into decimals, and compare it to the decimal that you find. But try to keep it exact so that way you can keep your mistakes to a minimum. Moving on to numbers 23 and 24. Here we have to find the exact value of the trig function. So that means we cannot just plug it into our calculator. So when we're doing these, we need to think to ourselves, how can we make this easier? For this one, for number 23, 5 pi over 2 is a huge angle. And I know that because when I actually try to find the decimal version of this, 5 divided by 2 is 2.5, and that's well above what one rotation is. So we could try to find the coterminal angle here. 5 pi over 2, if I want to subtract 2 pi here, I need to have a denominator of 2. So that means instead of 2 pi, I will be subtracting 4 pi over 2. That does not look like a 4. So 4 pi over 2. So I get pi over 2 as our coterminal angle. So that means tangent of 5 pi over 2 will also equal the tangent of just pi over 2. When we do this, we can refer back to our unit circle, but we won't have that on our midterm just like we didn't have it on our test. So we need to be using our hand rule here, or the fact that you have your unit circle memorized. So for our hand rule, if you bear with me as I draw a hand. Alright, pi over 2 is 90 degrees, so we're using our thumb here. And remember, tangent is always sine divided by cosine, which means here we would do our number of fingers below, square root of 4 divided by 2, the number of fingers above divided by 2. So we get square root of 4, which is 2 divided by 2, 0, so we get 1 over 0. So here we have 0 on the denominator, which means our answer is undefined. All right. For 24, we have to find the cosecant of 930. First, let's just talk about what cosecant is. That's one of our reciprocal trig functions. So cosecant matches up with sine. So we're trying to find sine of 930. Here, just as in the other one, it's probably easier to find the coterminal angle and start from our coterminal angle. So we're going to do 930, and since we're in degrees, we can just do 360. When we do that, we get 570, which is still pretty big. So let's do 570 minus 360 to see what we get there. And there we get 210. So here that means 1 over sine of 90. I'm sorry, 1 over sine of 930 is the same thing as 1 over sine of 210. So now we just have to figure out what this is. I'm going to move to the next slide because we're going to need a lot more space. We have to see how to do this without a calculator. So let's actually graph 210 degrees. So here would be 90 degrees, 180 degrees. If I go a whole nother quarter turn, that would be 270, which is way too much. So I'm actually just going to go a little bit, and that would be my 210. What is that just little bit? Again, I said this part was 90. Here's another 90, so that means what's left over to go is another 30. Here's what we were talking about when always we said reference angles. This angle right here, from the negative x-axis to our terminal side, that is our reference angle, and it's 30 degrees, which means whatever our values of our trig functions will be, will look very similar to our trig ratios for 30 degrees. We will have to do a little bit more work, which is just determine if it's negative or positive, but we can use sine of 30 to tell us what sine of 210 is. So let's think about this. First, let's figure out what sine of 30 is. So let's use our hand rule. All right, 30 is this finger right here. So sine is the number of fingers below, which is 1. We take the square root of that, divide it by 2. So here we just get 1/2. When we look at this, though, we're in a different quadrant. Our reference angles are always in, what we're referring to are angles in quadrant 1, but our angle here is in quadrant 3. We could remember this a lot of different ways, but we can just look at our terminal side. We can remember sine is always our y value, and here y is definitely negative. So that means sine of 210 would be negative 1/2, but we're finding the cosecant of 210, which is 1 over 1/2, negative 1/2. So that's negative 2. So that means the cosecant of 930 degrees is negative 2. It's a lot of work to do this, trying to be exact without a calculator. Lucky enough here, if you just plug this into your calculator, you would get negative 2, which is the exact answer. So a good way to go is to try to plug it into your calculator, find what the decimal approximation is, try to do some work and see if your exact answer gets the same decimal, or just a test taking skills, take the exact answers on the test, also find the approximate decimal approximation of them, and just compare your answers to that. Our last problem would be number 25. Notice here it said find the measure of each angle indicated. We never talked about how to find the measure of theta here. We only talked about how to set up our trig functions to find the missing side, and that's what was on your test. That might show up on the midterm, so hopefully I'll have my your test graded by Tuesday so we can take a look at those on our last day of class before your midterm. But we will talk about on this how to do, which is extra because it won't be on your midterm, but we can talk about how to use our trig functions to actually find theta and the other angle in our triangle. So if we look at this triangle, we have theta, we have what's opposite of theta, and we have what's adjacent of theta. If we remember back to our trig functions, that means we can set up tangent because we have opposite and adjacent. So we still don't know what theta is, but we do know the opposite is 5 and the adjacent is 15.4. The way that we can actually solve for our angle is we have to do whatever the opposite of taking the tangent of something is, which for us is just the inverse, and we always show our inverse by doing that, what looks like a -1 in the exponent of both sides. Alright, and it's kind of tricky to squeeze stuff in here, so that the tangent, the inverse tangent, goes to the left of this. So that means theta is equal tan inverse of 5 divided by 15.9. And somehow, because I have sloppy handwriting, those 4's turned into 9's. So that is a 4. So if we plug this into our calculator and we make sure we're in degree modes, we would get this big crazy long decimal which just continues on like this. We want to round to the nearest tenth, which here means we would round to 18.0 degrees. So that's what theta would be, but we still have one more angle here to find. So if I draw our triangle again, we have a right triangle. This one is 18.0, and we want to find out what our other angle is. We could use trigonometry again, but the far easier way is to say the triangle angles all add up to 180. And we know one is 18.0, the other one is 90, and the other last one is C. So we can solve for C by just doing C is equal to 180 minus 18 minus 90, and that means we get 72 as our final answer. So this question would not be on our midterm, but if we were to find each angle here, and we went above and beyond, I didn't realize that it said each angle indicated, but we could find each angle theta is equal to 18 degrees, and this other angle C is equal to 72 degrees, and our, angle B is equal to 72 degrees. C would, of course, equal 90 degrees because we have that right angle symbol there. So again, on Tuesday, we'll do an example that has a missing side, because that is a problem that we definitely did that didn't come up, but we'll probably just check your test for that. And there were some other things that didn't pop up on here, again from your test, finding all the trig values based on an angle, like what was on your test, filling out that table, and then we'll also talk about how to set up some other exponential functions, like exponential growth, exponential decay, and compound interest. So we'll talk about those on Monday and talk about any questions you have from this, since I think the last couple of questions all from this video were the ones where you all gave the most yellow post-its, which meant that you were you wanted to look at those the most. So we'll take a look at these. Hopefully these videos helped you. Let me know on Tuesday. Have a fantastic weekend.